should be pretty easy. First question is asking you the direction of F in this diagram. You've got B field, you've got current, you should have a force. Let me ask you, is this answer correct? Like, is it same as your answer? Yeah? So, which hand do you use? Left hand. Okay, so left hand. Let me check. F, B, I. B is going which way? Left, right? North to south, left. And I is going, according to this, to be kind of going out. So F, yes, going to be downward of this wire. This is correct. It would be nice if you draw the F from the wire. From the wire, that would be better. Number two, explain why the force will be acting on the wire. So it's something to do with, remember the catapult effect we mentioned. So you want to talk about the magnetic field by the currents carrying conductor. If a current is a magnetic field. A bit weird to say that. I mean, you got the words like currents carrying conductor, which is the wire itself, and they will produce a magnetic field. But they are not a magnetic field. They produce a magnetic field, which is circular, right? If you use the right-hand grip rule, it's circular. So maybe we rephrase this part a little bit. The field lines want to strengthen out naturally. That's pretty good words. Create a catapult effect. I would say not catapult force. I would say catapult effect of the wire. You also want to talk about the magnetic field due to the magnet as well. It's the interaction between these two B fields. I'll show you the actual marking scheme later on. Number three, direction of current and B field are both reversed. Is that no change? The answer is yes, no change, because both of them reverse at the same time, both reverse. Part B asks you to draw the force at point P when this negative. Negative is what? What is this thing? Electron. Very good. What's so important about electron? Current is opposite. Very good. So when you use the left hand FBI, F you don't know, B is going where? Tell me. B is going in, and I is going to the left. Very good. This is a very good annotation here. Because electron wants to go to the right, but the actual current in that case will be opposite. So force will be downward. So this one is okay as well. Again, if they ask you the force, Marcus, if they ask you the force at P, you want to draw from P. Yeah, that's will be much better. Can you guys also look at your own answer as well? Part 2. Describe the path when you continue to move. So I think similar to what we did in the previous lesson, it should be more like a curve. So if you are allowed to draw, although they ask you to describe, but if you are asked to draw, it should be something like this one. But you are not asked to draw but describe, so you may say curve downwards. I think this should be acceptable.
Can we say travels in a circle?
In a circle, actually in a circle might be possible. Actually depending on how strong the B field is. So if the B field is really strong, then it could actually turn a circle or actually go in kind of U-turn that way. So I think as long as you say the curve or the turn should be fine. Let's see.
Will it always eventually curve into a circle?
Depends on how strong it is. But in IGCSE, you are only doing it quantitatively. So it depends.
成日我不是，我唔知狗仔嚟，黐線，咁毒。而家我哋上咗晚7字，之後咧佢係咧，我唔知情嘅情況下咧會無啦啦開。
就係咁咯。 You can see here is a curve. I think curve is safer.
佢有 Q 出題㗎。
Curve is a safer option because circle, in a way, is also a curve. But you are not sure whether you can really complete the circle because it depends on B field. But at least it will be curve. Part B, I think I want you to pay attention to part 2. Look at the wordings. Can you check your own wordings with the official wordings? I will pick the first line actually, the first one. The magnetic field due to the current and due to the magnet interact each other. And that will be good enough.